For our next guest, we have ALPARSLAN AVCI, who works as a software solution architect for Hazelcast. He's a passionate Java developer and loves to think in distributed and object-oriented way. Prior to joining Hazelcast, ALPARSLAN worked in several Java projects, including a web search and an enterprise financial anti-fraud solution. He also contributes to open source projects like Apache Notch, and he's currently a PMC member in Apache Gora. If you talk with him, he will tell you that he loves to define problems and fight with them and solve them if he can. Let's give a warm welcome to ALPARSLAN AVCI in-memory data stream with Jet.
Welcome everyone. I will talk about in-memory data streams in this hour. It will be about the data streams with Hazelcast Jet. Let me talk myself first, as I've been introduced, but yes. My name is ALPARSLAN AVCI, and I am working as a solutions architect at Hazelcast. I am a former Java developer. I am not developing so much code nowadays, but my title has been changed in the years. But I like to solve problems if I can. And if you want to contact me, you can always reach me by using my mail. Firstly, thanks to Dan, he already asked that I already seen that much of you are developers, but I also want to check anyone using streams up to now. Any stream processing? Done? One? Okay. Anyone heard of streams? None? Okay. Okay, then it will be a good talk, I think, because we will talk the details about streaming data. Actually, streaming data is the data that is generated by thousands of, mostly thousands of data sources in a continuous and simultaneous way. And it's such it is mostly continuous, infinite data which is coming continuously. You can say that, for example, it can be some log files from the web applications or mobile applications, or sometimes e-commerce purchases, or sometimes in-game player activity, or maybe some information from social networks, or so on. And you get the data, but this data need to be actually processed to get the analysis, to get the results from the data. So you do it with some fashion. In some fashion, for example, you can do it by record basis, or maybe you can do it on a sliding time windows. And by using the data can be processed by using a wide variety of analytics, I can say. For example, correlations, or maybe aggregations, or sometimes filtering and sampling. And this analysis gives you the aspect of some business insights, or maybe some stats, or maybe some server activity. And also to the companies, it gives you to respond their emerging situations, to respond to the emerging situations. As an example to the streaming data, we can directly say the social media streams. For example, a company can track their brands on social media, and how the people are responding to their branding and the product usage. And also the company can respond back to the customers back there in a timely fashion, in the near real time. Another example can be talked as the stock market changes. For example, for a financial institution, they can track the changes in the stock market by using the streaming data, and they can compute the value at risk and rebalance the portfolios according to those analyses. We should also talk about the difference between batch and streaming at this point. Maybe you have much of you heard of batch processing than stream processing. Batch processing is the most we call also bounded data processing. It's mostly when you get the whole data set at your hands and you can access to the whole data at once. And you can probably doing the processing record by record basis. But when you come to the streaming, probably the data is unbounded. It's the mostly infinite data, and it is processed on the fly, in near real time, I can say. And you doesn't have to wait to the whole data set to be complete to make a streaming data process. And also, it has a significant benefit for the use cases that where the data tends to lose its value with time. For example, like the real-time business insights or some stats or maybe ad placement and fraud detection maybe. Yeah, so we have we learned something about Java streaming data, but with the streaming data, you should have some tools, some frameworks maybe to make Java streaming data available. Actually, as a Java development point, the Java with Java 8, data collections come with the streams. They can return streams like map or the, sets. And in Java, we can define Java streams as a sequence of elements that provides some kind of aggregate functions, I can say. The core functions of the Java streams are, firstly, they don't have any storage. They are not the default data collections like map or set. Instead, they are conveying the elements from the data storage, and they are just processing them, just conveying them, I can say. And they are functional in nature. They don't modify the data source. They don't modify the collection itself. Just do some operations on it. And probably, possibly, they are unbounded. They don't need to be have a finite size like the data collections. Yeah, let's have a small demonstration on with the Java streams, the classic Java streams. Let me check if I can manage to see my screen. Yeah. It should be a little bit hard at this point. Yes, can you see the screen from that point? I'm not sure, yeah. Yeah, actually this is a simple application with the word count example. Probably you have heard word count example because it is mostly used and when you are demonstrating the big data examples. And here we will do the word count in a book, the book of the Tolstoy's book as far as I know, War and Peace. Yeah, War and Peace English book. At first we are populating the map to a hash map. It's a simple hash map, the data collection in Java. And later on, we are getting in here, you can see, we are getting the enter set and making as a stream. This is a default Java API, not adding anything right now. And using flat map, this is another function that makes the flattening the map, actually, I can say, and applying a filter operation and then collecting into another map. I won't go into details of these methods because there are lots of methods like this on the API. You can go and check on the internet to see the details. Just to see how it works, let's make it work. Yeah, it's, as you can see here. It counts the words, and as you can see, at most the keyword is mostly used on the book. So it's simple. It's not so much details on it. So let's go back to our presentation. Yeah, we talked about the Java streams, but there are some problems with it. The main problem is that it's working on a single JVM. It means it's not distributed. The non-distributed systems comes with some problems on on much of the use cases. Firstly, we can talk about the parallelism. Yeah, Java comes with some kind of parallelism by using multi-threading, but you are still bounded to only one box, one server. So you can only start one JVM and you can go with it, but you cannot use any other JVMs to communicate with the same one, unless you are using your own built application framework. Another problem is the source and sinks. Actually, when you are using default Java streams, you are mostly, again, bounded to the very basic sources, data sources, since mostly they will be the JVMs itself data collections like hash map. And also, when you need the scale up, when you need scaling, you can be only do the enhancing the box itself, enhancing the server. You cannot do any scale up, scale outing, scale horizontally. You cannot add any new boxes to your application. And so we can say that we need distributed systems. Yes, we need a distributed application framework at this point. But you can build it, of course, you can build by yourself to try to do this, but you will face lots of distributed systems problems. So here comes Hazelcast Jet. How many of you heard of Hazelcast? Anyone? Okay, more than once, good. Actually, Hazelcast is an in-memory data grid. It is providing the default Java collections in a distributed way. You can use, for example, IMAP, ISAT, which are the distributed versions of the Java's default set and map implementations. Hazelcast Jet is another product, is another project in Hazelcast umbrella, I can say. And it's a distributed computing platform for fast and batch streaming, fast stream and batch processing of data. And it operates in near real time, and it is using directed acyclic graphs as the modeling of the data processing in behind. The directed acyclic graphs is a mathematical term to use, which is used to show how you can build your data processing. And Hazelcast Jet can execute both batch and stream data, and it also adds distributed implementations of the Java util stream library, as we talked in the previous demonstration. Yes, let's have a look at the jet implementation of this word count. It is not so much different as you can see here. In the first two lines up here, it's starting a new jet instance. It means that it is creating a new node, a new instance, a server node, and here you can see that it's starting another one, and they are autonomously building a cluster in background by using multicast. And then here we get a streaming map from Jet, which is name is lines. It's creating this stream map. And then we are again populating the map, and here you can see that it's nearly the same. We are getting now, we are using this lines stream map, and we are getting again another stream, and we are applying a flat map operation, a filtering operation, and then collecting it to the distributed collectors. We are reducing the data to a Hazelcast map. Let's also run this one. Yes, at first it's starting the first instance, and now it's starting the second instance. They are building a cluster in behind. Yeah, they have built one. Now you can see there are two members, and they run in behind, and you can see, we can check out, sorry. Yes. We can check out the results from here. It's the same, but now we are working in a distributed environment. You can see that there are two instances which are running on my local laptop here. Of course, you can run it on a network, and you can use as many of you needs the instance. So if we come to the essentials of the Hazelcast Jet, first it's simple. It's that simple actually. As you can see here, you can, with one line of code, you can start the instance, and you can also have the details, and you can get the value of the Hazelcast Jet in, I can say, in 15 minutes. You just add the library to your class path, and you write one line of code, and your cluster the first instance of your cluster has been just started up. And the configuration is so simple. There's only one XML file, and by changing this XML file, you can configure your cluster. Also, it is lightweight and embeddable. It means that it is actually it is just a library. It's not a server. So as I said, it can you can use it your applications on your microservice applications especially, and you can build your own processing engine by using Hazelcast Jet. And its discovery properties are really good. It uses basically it uses multicast, but it can also use some other discovery mechanisms like Eureka or other discovery mechanisms. And also the Hazelcast Jet allows you to use lots of cloud deployment options like Cloud Foundry and other ones. And surely the main feature of Hazelcast Jet is open source with the Apache 2 license. So you can get Hazelcast Jet freely, and you can use it on your commercial products, commercial development without paying anything to any company. Yeah. If we talk about some features of Hazelcast Jet, firstly, we need to talk about windowing. Actually, data streams are mostly unbounded, as we talk, and so you need some tool to make a frame of some data which we called the term of windowing here. Actually, Hazelcast provides you some windowing options. There are three main windowing options in Hazelcast. This first one is fixed tumbling, also it's called. The second one is sliding, and the third one is session windowing. The first one, think this the first line as the data stream, and as you can see, the fixed windowing, you have a fixed size of window, and the events, the data, does not overlap over the, does not be used in multiple windows. And in sliding window, again the window has the fixed size, but now the window is sliding over the data. So the events or data can be used in multiple windows. And the last one is the session windowing. It's actually mostly not continuous data, we can say. It's, the session is defined with some constraints. And by using these constraints, you can define your session. And also, as you can see here, the session, the window can be can get a timeout after some time or when it's idle. Another feature is event time processing. Most of the streaming data should have the event time in the data. And when using the event time processing, you may need to use that the origin of the event's time. So Hazelcast allows you to do this event time processing, and there's a set of policies that you can use, and you can decide on if you want to whether the event is late or at its time. So you can define by using these policies. Also, in streaming systems, it's necessary to control the flow of events. Since it's used, we can say there are unbounded stream of data. You may be the consumer of your data can be flooded by high number of events or data, and also on the other hand, maybe the processors also can have some time idle and wasting resources. So Hazelcast provides some back pressure mechanisms and behind to prevent these problems. Although JET is a streaming engine, it's also used for batch processing and using the ETL processes. So you can define your batch processing engine, and you can use it on your bounded data. Actually, the most core function on this one is you're building the DAGs, the directed acyclic graphs. By using them, you can do whatever you want to do with your batch data. And it's also fault tolerant. It means that, of course, you can face some faults on your stream processing. So Hazelcast can find this faults, and it can cancel the operation, or it can reinitiate the job as you wish. In streaming terminology, we call source and sinks for the source data and the output data. So Hazelcast also provides you to use some of these source and sinks. Firstly, Hazelcast IMDG can be used in Hazelcast Jet as a source or sink, the maps and lists and sets. And also you can use a file. There are file readers and file writers on Hazelcast Jet that you can use. And also you can use basic text-based sockets to read or write data. And also, if you have already a Hadoop HDFS installation, you can use that HDFS data as a source, or also you can use as a sink to Hazelcast Jet. And we have also some Kafka streamers and writers to use the topics of Kafka in your as the source and also as a sink. And here I should say that maybe especially on stream data processing, if anyone is interested, probably it will go to looking at the Apache Spark or Apache Flink. Because these are the most popular streaming engines in these days. But I can say that the core functionality is not so much different from Hazelcast Jet. But Hazelcast Jet provides much more performance with comparing to other the Spark and Flink. In here you can see that this is a simple benchmark. It's not a detailed one. Of course, it depends on the use case that you are working on. But with the word count benchmark, you can see that the throughput with Hazelcast Jet, the blue and the green bars are for Hazelcast, and the red and orange ones are for Spark and Flink in order. The throughput of Hazelcast is really high. I will explain how we getting these results. And also with the streaming word count, you can see that the average latency is so low when you use Hazelcast Jet in comparison to Flink and Spark. The first reason that we are getting so much performance is the data locality, in memory data locality actually. Especially if you use Hazelcast IMDG as source and sink, or Hadoop HDFS, you can use Hadoop HDFS can be used on the data FNT, not in this part, because in this part, by using Hazelcast IMDG, the maps and sets, you can get the advantage of getting the same place when you do the computation and the storage. So you can store the data at one memory chunk, and you can also do the computation on the same box, and you don't need to transfer data on the cluster. That will give you lots of performance gain. The other one is the partition mapping affinity. This one is that you can make a correlation between the objects and the partitions in the distributed cluster. And so again, this will give you the advantage of getting the same location for the partition threads with the objects. The most important one is the green threads, cooperative threads. Actually, this is green threads is a multi-threading concept, but Hazelcast Jet is using this one. It's the processor API is simply designed in a way that the processor can do small amount of work and each time, and then it can yield back the thread to the jet engine. So in basic terms, I can say that we are dividing the same operation into multiple parts, and using the on the same thread, we can by using the same thread we can use multiple processors on the same thread. This will give you the advantage of this will prevent you the problem of context switching actually. So you don't allow the operating system to make the context switching in backend, and it is doing the processing in libraries in the JVM, I can say. And it's a purely library level feature. It's not there is no any low level system or JVM tricks at this point. You can use the API the processor API that gives you the ability to divide the operation into multiple pieces. And it also gives you the core affinity part because it's mostly when you use the same thread with the same processor, you can get the core level caches at the mostly of your processing. And yes, actually, this end of my presentation. You can use jet.hazelcast.org to access to all the documentation and all the resources. If you have any questions, I can try to answer.
For the Q&A session, I strongly ask you to present yourself, maybe state your name and the company where you're coming from. Thank you.
Okay.
If anyone doesn't have any questions, then I will maybe ask one. You made an open source project again, the JET.
Yep.
If the guys from the room will want to use it when they come back home, what will be some typical use case for them that you would like to share?
Yeah, actually, for now, the Hazelcast Jet is now being developed more than 2 years, I can say, and we publicly announced Hazelcast Jet in February 2017, which is not more than 1 year. And we have now some, especially in some banking operations, we have some use cases, mostly on financial use cases, I can say. But as I said, we are expecting to be used mostly on the other social media streams, maybe the analyzing social media streams, or maybe some other log processing and getting the advantage of analyzing big data, I can say.
Thank you.
Yeah.
Any other questions from the room?
Okay,
No.
thank you very much.
Thank you.
Thank you for listening.